Every radio amateur should know about the basics of a radio transmitter, whether you are going to operate a commercial one or make one on your own, what we call by the pet name homebrew. A radio transmitter is a device which generates a radio frequency signal and sends it out as radio waves through the antenna. If only the radio frequency carrier wave is sent with breaks and makes corresponding to the Morse code formerly used in telegraphy, then it is known as CW, continuous wave transmitter, which is the simplest one. Like many other radio amateurs in the yesteryears, I had also homebrewed a basic CW transmitter using BD139 transistor as the final RF amplifier, running about 5 watt, known as QRP transmitter. Initial part of the transmitter is the radio frequency generator, known as oscillator, which produces a high frequency oscillating current when you supply it with a direct current power supply. Oscillator section was called a VFO, or variable frequency oscillator, as the frequency could be varied within the amateur radio band using a tuning circuit with a fixed value inductor and a variable capacitor. Single frequency crystal oscillators were also there, which had high stability as the frequency depended on the vibration of a quartz crystal, which would be constant at a given temperature. Power output of the oscillator or VFO would be very low and needed several stages of amplification. Initial stage of RF amplifier can be called as a preamplifier. Output of the RF preamplifier is further amplified by the next stage, which is known as the driver stage for the power amplifier. In the VU to VWN circuit, which was popular in 1980s, VFO had two field effect transistors known as BFW10, and the RF preamplifier was SL100. Driver stage for the final power amplifier had SK100. Both SL100 and SK100 were bipolar junction transistors. SL100 was NPN while SK100 was PNP transistor. Final power amplifier BD139, an NPN transistor, could deliver up to 7 watt output. Some used to call it a 7/7 transmitter because initial design was for the popular amateur radio band at 7 MHz or 40 meter. Oscillator circuit would run continuously and driver stage would isolate it from the sudden changes in load while keying the amplifier for Morse code DIT and DA, dot and dash. Higher power transmitters would have more driver and buffer stages compared to the simple low power or QRP transmitter. Next level of sophistication in a transmitter is adding a modulator for voice transmissions. Voice signals from the microphone will be amplified by an audio amplifier and used to vary the amplitude of the carrier wave generated by the oscillator and amplified by the power amplifier. This process is known as modulation, and the simplest form is amplitude modulation or AM. In VU to VWN QRP, TBA810 integrated circuit was used as the audio amplifier for the modulator. If the voice signal is used to modify the frequency of the radio frequency signal, it is known as frequency modulation or FM. Modulation can be applied at the final RF power amplifier stage or at the driver buffer amplifier stage. The modulated signal received from the antenna in a receiver is demodulated by the demodulator to extract the audio signal from the radio frequency carrier. The whole process is needed because sound waves can travel only short distances, while radio waves are much faster and can travel much larger distances across the globe. In modern radio transmitters used by amateur radio operators, single sideband or SSB is used to maximize the range with lower output power. In single sideband transmitter, the audio wave modulates the RF carrier wave in a section known as balanced modulator, which has the output as double sideband without a carrier wave. Both sidebands have same audio information for demodulation, and hence one sideband can be removed using a sideband filter, which reduces the signal level sent to the final power amplifier and makes the transmitter more efficient. Removal of the carrier removes the bulk of power requirement in an amplitude modulation transmitter. Only a small portion of the power is carried in the sidebands compared to the carrier wave. So, if only one sideband is amplified and transmitted in SSB mode, the received signal will be at least 4 times as much as the AM signal for a given power input to the final RF amplifier. Conventionally, lower sideband or LSB is used for frequencies below 10 MHz and upper sideband or USB for higher bands.